know Elasticsearch? Like, if anyone of you know Elasticsearch, let me know. Apart from the managers, no one. Mayur, Vaibhav. Okay, so only okay, only two, three people know Elasticsearch. Okay, cool. So, like, I was expecting much more people to know about it, but I think then this is good. So I have prepared this presentation from the very basic of Elasticsearch, and okay, I'll explain you what is Elasticsearch. Uh, Elasticsearch is actually a very big, a very vast concept. Like, if when I started learning Elasticsearch, I took like at least a couple of months to understand it and implement something on Elasticsearch. Okay, so it's very huge. Like, even the normal search queries are, like, it has so many options. It'll be very it has a very steep learning curve. Okay, but we'll go through very basic. We'll go step by step. Okay, so what is exactly Elasticsearch? So whenever you go to sites like Flipkart or Amazon, you just search for one particular item and it gives results instantly. There may be billions of records in their databases, but still you get answers in less than a second. How is that possible? That is possible through Elasticsearch, because it has a highly indexed data structure. Okay, so it is distributed in the sense it's not centrally managed. So let's say if there are 10 servers, you can query any of the server and you'll get the result. Okay, it's scalable, real time, and it's built on Apache Lucene. Apache Lucene is an open source software. There is another software just like Elasticsearch called Solar, on which our YP team is working right now. That is also entirely open source. So these are the two platforms, like Elasticsearch and Solar, which supports uh, this kind of search. So Elasticsearch basically comes with three things. It's called ELK stack, which is Elasticsearch, Logstash, and Kibana. Kibana is a UI for Elasticsearch, and Logstash is like an aggregator of data for Elasticsearch, which is used for putting data into Elasticsearch. Okay, what are the features of Elasticsearch? Are like it supports full text search, real time indexing and search, scalability and high availability, RESTful API and JSON based queries. So just to summarize this, it has the backend is called Elasticsearch. Just like we have dbeaver, right? Dbeaver is used as an UI for accessing our Postgres or MySQL databases. So here Kibana is used as a UI for accessing Elasticsearch. Okay, and all the communication happens through REST APIs. Whenever there is a query that we want to do to Elasticsearch, we need to write REST based queries. I'll come to it. We'll have hands-on experience on this as well. How does it compare to NoSQL and search engines? So, as you all might know, SQL is like we have relationships between tables. We have dependency keys like foreign keys, primary keys, and everything. So this is a normal SQL and normal relational database. Okay. What is NoSQL? NoSQL is storing JSON documents inside a database is called NoSQL, and then we can query those JSON documents. Elasticsearch is a variation of NoSQL. Elasticsearch also stores JSONs, but it is uh, highly indexed and highly available data structure. Okay, because it tokenizes each and every word and then stores the inverse index. So here, if you see in the diagram, if let's say if in a database there is a column which says the bright blue butterfly hangs on the breeze. Okay, so it breaks down each word into tokens or terms and then stores this token appears in which documents. Okay. Check the second document. Under blue sky and bright sunlight, one need to search around. Okay. So here blue appears in the first as well as the second document. So in the indexing, what it does is, okay, there is a blue keyword. If somebody searches blue, I'll present them with one and two documents with ID one and two. So this is how the inverse indexing works on Elasticsearch. Okay. So guys, if you have any questions while I'm explaining, you can just stop me and ask me. I'll come to like whenever I come to the hands-on experience, I'll explain you more on how exactly this is done. Okay. Uh, where do we use Elasticsearch? So Elasticsearch, obviously, it's used in search engines. Basically, it's used more where we require a lot of analytics. So where let's say we want to monitor a lot of log data. Like let's say if we have scaled on server which is like has 10 to 20 different servers, and we want to monitor each of uh, those servers, then this Elasticsearch helps a lot in it, because searching becomes very easy, and we can have the data precisely, and we can search it very briskly. Okay. So this is used in log and event data analysis, security analytics. So each and every security event can be logged here. Business analytics. So let's say if there is a company which has orders coming in like 1,000 orders in a minute or something like that. So if we want to search the logs for how what exactly is the throughput and how the business behaves, analytics can be very very important in this scenario, and data should be readily available in this kind of scenarios. So this uh, Elasticsearch is used there. Autocomplete and suggestions. So autocomplete and suggestions is the one which I picked up from our YP project. Um, let's say if I am creating a search engine, right? And if I'm typing something today, you see that okay, Google is showing you an autocomplete words after what you're typing, right? So if I'm typing, let's say pizza, okay, this is my search engine, and I'm typing pizza over there. I'll give you results which are nearer to your place. Okay. So auto suggest on autocomplete and suggestions, I'll give you only those options in autocomplete which are nearer to your place. So this is where Elasticsearch will be very useful. Geospatial data is where location based search. Just what I mentioned. Like let's say if I am at a particular location, okay, Elasticsearch helps in finding um, geo-based locations and data, because it is dependent on a centroid related technology which uses coordinates for searching on the documents. Okay, so it has vast use cases. Where it cannot be used is we cannot use it for transactional database, because Elasticsearch is not asset compliant, so it does not support transactions. Transactions, by transactions what I mean is like we cannot guarantee that okay, one particular record will go, a second record will not go if the first one fails, and so on. So we cannot use this in the banking systems. We cannot join multiple data, and we cannot do like an aggregation of different kinds of indexes together. It has a like we can implement multiple index search together, but that's an advanced topic which we'll cover in the next session. Okay, so these are the uses of Elasticsearch. Okay, coming to the basic concepts of Elasticsearch. So whenever you are using Elasticsearch, um, what is an index? Index is called like is like a database in RDBMS. So let's say if I'm saying that okay, I have a student table, okay, and then that a table becomes an index in Elasticsearch. Record becomes a document in Elasticsearch. Okay, so whenever we have one particular JSON inside Elasticsearch, that we call it as a document. I'll explain more when we are doing an hands-on. Okay, shards and replica. A shard is a component wherein we divide our data and store it. Okay, so let's say I have millions of data with me, but one particular instance of Elasticsearch uh, does not store that much of data. So I can divide my data into multiple instances of Elasticsearch. Replica is just a copy of my instance, so that one particular instance fails, another can take over. Okay, and this is inverted index. So that's what I explained in the previous slide, like how exactly inverted index works. It stores uh, tokens, and against the token, it stores the number of documents. Okay, moving on. Okay, so we'll move on to the installation. So installation of Elasticsearch is pretty simple. And guys, I need all of your attention to whatever we are doing, because after this session, there is a project coming on for Elasticsearch, and we need a couple of people to work on it. So we can choose anybody after the session, and you can't say that I do not know Elasticsearch. Okay, so yeah, so Elasticsearch is just this one. Only this part is Elasticsearch installation. So what it has, we just select the image. Mostly Elasticsearch is hosted on this port 9200. Discovery type is single node. That means we are just having a single node right now. It can scale up to multiple nodes and multiple clusters, but we are just using single node right now. This is for password security. We are not having any password right now. And then this is how much memory I'll allow him to use. So this is just Elasticsearch. You install this and run your Docker. Elasticsearch will be up and running on your system. Again, this is Kibana. Kibana, you need to tell you Kibana which Elasticsearch instance you want to point to. So you just put this over here, and it will be up and running. So I'll just did that. So this is the same file. Okay, yeah, it's up and running right now. So if I go to localhost 9200, yes, I can see Elasticsearch is up and running. The version is 781.
Ronak, so could you show that on the screen? We are currently seeing the slides.
Sorry, I'll just share it. Okay. Do you see it now?
Yes, sir. Thank you.
Okay. So if I just do localhost 9200, it will show me this, and it will show me that, okay, this is the version of the Elasticsearch that I have installed. And where is Kibana? Kibana is at 5601. Okay. So both of them are up and running right now. Cool. Next. Okay. Um, how do you create an index? Okay. So let's say I do not have. Okay. I'll come to Kibana, and then on Kibana, I have a tool which shows my index management, stack management, index management. Okay. Currently, it shows that I have one demo index. Okay. So as I explained earlier, the database that we have in our DBMS is called index over here. Okay. How do we create a new index? We go, and if we just um, do anything like we are putting a document, like let's say post students doc one, okay, or I'll just say post for doc, just something like this, underscore doc slash one. mm, product. So this is entirely HTTP request and response. Okay, so Kibana provides a special dev console for interacting with Elasticsearch. Okay, created. See, in my instance, I did not have any particular index which is called product. Okay, I specifically named it as POR because I want to delete it afterwards. Okay, so if I go here and then refresh this, I'll see another one. A new database has been created. A new index is created. Let's call it index from now on, which is called product. Okay. So what I did over here is I just created one document inside product. So it understood that, okay, this is the name of the index, and I want to put a document inside that index, which has just one parameter, which is called name. Okay. So here we can create index just by putting any JSON inside Elasticsearch, but we should not do like this. We need to define a structure for the JSON that we'll be putting in, and only after that we should be putting data inside it. Okay, so let me delete this. So deleting index is as simple as this. So now if you see, there will be no index here. Okay. So how exactly we should create it? This is called a mapping. Mappings mean uh, what kind of uh, parameters your document will contain. So we'll tell Elasticsearch that, okay, my particular document will have name. So treat it as a text. It will have age. Treat it as integer. It will department, GPA, enrollment date. Okay. When you send this to students index, it will create, okay, it will create an index over there, and you will be able to see that, okay, this index has this settings. I'll come to the settings, and then it has these mappings. So this mappings, whatever we just pass to it, it will show that, okay, this particular has mapping. So these mappings are important from the point of view that this thing decides what kind of data we have. Okay, we can have multiple parameters, and we can have multiple fields for the same kind of data, and we can replicate that as well, and which is another topic. Another session will be required for that, but we'll continue with this. Now this does not mean that you can only enter these 5 fields inside my document. You can have 50 fields. Okay, those fields will also be created. It will also be stored in Elasticsearch, but these 5 fields will be with a specific data type. Okay, and those other 45 fields will be treated as a normal text. Okay, cool. So now we have created a index called students with name, age, department, GP, and enrollment date. So if I want to query this students index, okay, so I can do this, get, and then all match all returns all the records which are there in the index. Okay, so currently it says that it does not have any record inside it. So let's create some records. So this is the first record. Okay, it says created successfully. This is the second, and this is the third. Okay. Now again, I'll go and do a search. Yes, now it shows that there are three records, and these are the three records inside my structure called students. Okay. So searching in Elasticsearch is again a huge topic. I'll just show you a basic search how it can do. So if you want to search for a specific column over here, so I want to say that okay, search for department computer science. Okay, so who is here? Rahul is from computer science department. So the type of query that I'll do is query. So everything is JSON and REST over here. So you type it like this, call a get API, and then it will search for you. So did you see how fast it was? Like, I know it is only three documents, but even if you have 1 million documents, it will return the results with the speed. Okay. There are, I'll show you another variation of search, which is called Boolean search. So, like, let's say if you want to have conditions in your query where some of the fields must be present, some of the fields should not be present. So, here, this is how you can specify the query. Write bool over here. Bool means it can go with and or kind of statements. Okay, so what I want is I want a range where GPA is greater than and equal to 3. Okay, and let's just do this for now. Like GPA is greater than equal to 3. So all of them have GPA greater than equal to 3, but Rahul has GPA 3.8. So let's say greater than equal to 3.5. So I should return only, I should get only, or should get 2. So 3.6. So I should get only Rahul now. Okay. So this is how the query is done. And now I want two things, like it must match this range and it should have, and now there is another keyword called term, and it should have a, it should be in the department electrical engineering. Okay. So do we have something like this? Yes. Priya Patel is having GPA 3 greater than equal to 3 and she's in electrical engineering. So this is how search queries can be defined and explored more. Okay, we can have aggregations as well. Aggregations means if you want to group by some terms, if you want to have averaging out, summations, counts, so all those also can be done. So here is a small example of it. So here we just mentioned that ax, we name this field as average GPA. Average is, this is a function. Okay, and on which field we want, which field, it's called GPA. Okay, so if I run this query, okay, I'll get the three records, and then average GPA value will be 3.5. Okay, so 3.2, 3.5, and 3.8 will give me average of 3.5. So this is how aggregation can be done. Okay, so this is just a start, guys. Like if like, there's a lot to explore. I just showed you how we can create, insert, search. If you want to delete, you just can delete. Like what is the ID here? Like let's say if I want to delete Amit Kumar, so I can do, so you need a delete API inside students and ID 3.
You need to add doc underscore doc.
Yes. Yep. So it's deleted. If I do this, now it's deleted. Okay. So these are the CRUD operations that we can do on Elasticsearch. Okay, I showed you this: creating, adding data, searching, aggregating. Okay, moving on to Kibana. So this was Kibana. Okay, so Kibana is a very exhaustive tool to represent all your data. I'll just give you a glimpse of a demo data that is present over here. I'll go to, let's say, dashboard. Okay, so this is the dashboard of the previous index that I had shown you. Okay, I'll show you that index as well here. Yeah. So this is the index called sample data. So it has 4,675 records. And these are the kind of records that are stored over here. And based on this data, the dashboard has been created. This dashboard. Okay. So this is a really good tool to like have your data being displayed to your managers or anyone who
That
is responsible.
Ronak, that charts and those dashboard that will automatically created, or we need to
No, we need to create. That's what I'm coming to.
okay.
Okay, so discover tab. So what is a discover tab? I go here, and here in Kibana, we have a discover tab. So discover tabs will show you all your data. Like we don't need to do any HTTP call, or we don't need to go to dev console. If somebody is like not tech savvy, he can come here. He can see the entire data from here. Okay, so we just had two records left. So those two data are currently displayed over here. Okay, so this is the discover tab. You can see this kind of fields over there. If you want to add a new field, you can do that over here as well. Okay, so this is the discover tab. Filtering students by GPA, we can also do that. So here we can search for, let's say, age is greater than 20. Okay, so both of them are age greater than 20. So this is how you can, it's this tool helps you in understanding Elasticsearch, working with Elasticsearch without knowing any of the technicalities. Okay, and then the visualize tab, creating a bar chart of the students. So if I go to visualize tab, here you can create data. I just created this. If you want to, like, this is the graphs that you can create, the dashboard that I showed you earlier. We can create small components over here and then put all these components on the dashboard. Okay, so here you select that what kind of chart you want to make. Okay, and then provide some metrics that what should be there on the x-axis, what should be there on the y-axis, or what should be there in the slices. Number of students, like let's say here I have put in age. So there is one student with age 21 and another student with age 22, and so on. Like you can create a n number of graphs over here. Okay, so this is the visualize tab, and then creating matrix visualization. I just showed you that. Dashboard tab. Okay, the one that I just showed you, dashboard tab. I think you guys can create one small dashboard tab with all the information that I had shown you as homework, and the people who will choose for the task that we have, they'll need to show me first how exactly they have done this dashboard tab, and then we can see which work can be given to them. Okay, take this as a homework. Create the same students index and provide some graphs on the dashboard. Okay, so I've given you some indications like student distribution by department, average GPA, student list table. So provide 2 3 different structures on the dashboard and take it as a homework. So it's very simple. If you want to install it on your local, just in this, I'll share this presentation with you. You can take this and install it on your local and then start working on it. Okay, so the dev tools console, the thing that I was showing you, this one, where exactly it is, this is present in here, dev tools. So if you open this, you'll get this. Okay, so this was a basic overview of Kibana and Elasticsearch. Anything else I'm pending? Yes, future topics to explore. So as I told you, like it is a very huge topic, Elasticsearch and Kibana. Like people just have their entire lives dedicated to Elasticsearch and Kibana. So a lot to learn, and these can be the next topics like advanced query DSL, Boolean queries. I just gave you an example. Nested objects, performance tuning, shard allocation, caching strategies, data pipelines, machine learning with Elasticsearch, security features, and scaling strategies, cross cluster search, hot warm architecture. So there are like this things at the end are related to more of an implementation perspective, but to use it and like start using this particular application, it's pretty simple. We can start with the small baby steps, and I think you guys will uh, do wonders. Any questions?
Sir,
Yes,
uh, actually, how it internally works, like Elasticsearch, like what internally it does basically.
I explained you in this slide, right?
Yes,
So
but uh, you can say like internally, like algorithm or something like.
yeah, so this is you I told you, right, this is Apache Lucene. Apache Lucene is an open source software which is mainly concentrated on having such kind of softwares which are highly available and highly indexed. So like, right, like whenever you are creating a table and uh, your queries are slow, right, so you create an index on it and then it becomes faster. Why does it happen? Because after creating the index, each the database knows that if you are searching for a particular word, where exactly it will be in the table. So if there are 10,000 records on a table, it just needs to scan like few like scan that index and know that okay, your particular record is at this particular location. So this implements high level of indexing on all the records and all the tokens that it gets. So let's say if this particular sentence it wants to store it in Elasticsearch, so it will break down each word. It will break down each word, and then against each word, it will store which document it appears. So if somebody searches, let's say blue, it will uh, go to this index, fetch for document 1 and 2, and then it will serve to the user. This is how it's stored in Elasticsearch.
It means it use only indexing only, uh, right?
Indexing, hashing, a lot more technologies are being used, but yes, mainly indexing.
Okay, sure. Thank you, sir.
Ronak, in the document, it data saved in a JSON format, right?
Yes,
Okay.
yes, everything is stored in JSON format.
Mhm.
See here. So for any document, so if we are not providing it any ID, it will generate its own ID. So if you want to just specifically search for one document, you can search by this particular ID. Okay. Any more questions, guys?
Sir, I had a doubt about the installation. I didn't get how the installation will be done.
You know Docker? Have you worked on Docker?
No.
No, right? Okay, so just install Docker. Okay, install Docker engine. Okay, and once it is installed on your system, it is available for all the systems like Mac, Linux, Windows, everything. Okay, once this is installed, okay, copy this file. I'll share this particular presentation with you. Copy this file and put it in docker compose.yml, and then just run docker compose up -t, and it will start running. Okay, I'll take another session on the Docker as well. Like, people need to know what is Docker.
Okay, sir. Thank you, sir.
Any more questions, guys? Okay. Thank you, everyone.
Yeah. Thank you, Ronak. Thanks.
Thank you.